Okay, welcome everyone for my talk about Kotlin and AI. I just realized I have a bit more time than I thought, so well, I don't have to speak so fast. That's very convenient. Well, very short about me. I'm already introduced. I'm a developer, right? I try to be as much as possible with my hands in the dirt. This is where the real pleasure is happening. But also in short particularly is training. Might have heard that too. So I help Kotlin developers to reach their next level, no matter whether you're beginner, intermediate, or also advanced. I'm a certified trainer, so it's good to hear, and I'm a frequent constant speaker. I'm also co-organizer of Kotlin Dev Day, together with company Flock, Team Flock, we already heard it, so 27th of November. Might be interesting to mentally note in your brain. Will be a cool event. Okay, enough about me. I'm actually quite curious about you in the sense of your AI consumption. So who of you is more or less using a chat-based application like ChatGPT? Raise your hand. That's almost everyone, right? So nowadays, it's a very common way of leveraging our work. So who of you is using AI-assisted coding? So like Copilot or a tool like that? Okay, that's about not half yet. Cool. So who of you is using agentic AI to create code? Like Tuni we've seen this morning. That's, I guess, even less indeed. Interesting to ask maybe over half a year. Now, another question is, who of you has programmatically interacted with an LLM? That's also not that many. Cool. Then last question, I'm curious whether one hand will rise. So who of you has brought an application to production that does something with an LLM? Okay, there are a few hands. Cool. Okay, nice. Got a bit of impression where we are right now with AI. Well, when we talk about AI today, we're actually talking about these beasts here, right? The LLMs, large language models. By now, they have also different kind of variations. You have the RLMs, the reasoning language models, and the SLMs, the small language models. They keep on extending, but in the end, they're language models. And today, we're going to look at LLMs from a developer perspective. For us developers, an LLM basically is just a black box, right? And when you want to interact with an LLM, you need to run one. So how can you run an LLM? Well, you have this cool tool set called Ollama. Who has heard of Ollama? Quite a few, nice. So you just can spin up one of the open source models, and then you should be able to communicate with an LLM. Kind of as an extra, cool to show, I did that too, of course. So for instance here, for the ones who haven't seen it, I have now the Mistral model, and I'm asking how many R's are in the word strawberry. And it says there are 2 R's in the word strawberry. Okay, but this is not a reasoning model, right? It's just a normal model, by the way, from European soil in France, Mistral. But with counting, probably has some problems. But as I said, the good news is, by now, we also have reasoning models. And I'm using DeepSeek, the Chinese disruptor, so to say. Reasoning model, they're actually, in essence, more or less the same like traditional language models. They're just trained a bit different with so-called reinforcement learning, and they work with the so-called chain of thought. So they split up a sentence into sub-sentence, and kind of heuristics have proven that by doing so, you get just more, and you get more reliable results, so less hallucinations. You see that it does quite a bit of thinking. I mean, it's also a hard question, right? How many letters are in the word robbery? This really takes long, and it's nice because I recorded it so I can speed up things a bit. And if you look closely, it also starts re-reasoning. So it does some output, saying, maybe that's not, let's okay, it keeps on doing that. But you know, that's fine as long as my result is what I expect. Okay. Well, it's kind of fun, right? But I think this is very, very important to realize. LLMs are by definition totally unreliable beasts. And this is not how it's definitely solved, but it is that way. And it probably will also stay that way because they're trying to solve this problem for very long, but they probably cannot solve it with the current state of the art. So this is always something very important to keep in mind. Also with all the stuff I'm going to show you today, which all looks fancy, there are about 100 ways to kind of break it. Okay, well, if you want to create something serious, you're probably not going to run LM on your local machine. You're going to run it in your cloud. Maybe your Google Cloud using Gemini. And the good thing is when you run a model there, you can also send sensitive data to it. So if you then have some tokens, that's fine. When you use one of the public offerings, then be careful. Sensitive information might end up in a training set. However, if we zoom out, we could say that an LLM is just another piece of middleware with an API in front of it. So actually, we're just talking to just another API, but a special one, but in the end, it's just another API. And when there is a case where we have to interact with a piece of middleware in a structured way, frameworks are mostly around the corner. On the GVM, we have these two choices. It's LangChain for J, a bit based on this LangChain project in Python, which is already quite some years old. And it does all these things here. And should you know what all these mean, then I have good news for you. Once you leave that room today, you will know all of them and even know how to leverage them for your own good. The other contender in this space is Spring AI, which more or less really has the same capabilities. They have some strengths and weaknesses, but overall, I couldn't make up my mind and say this one is better than the other. It depends. So, what's definitely important to mention is that LangChain for J runs on all major GVM frameworks. Right, Micronet, Quarkus, Ketor, then you've had it, but also Spring Boot, so it also works very well together with Spring Boot, whereas of course Spring AI only works on Spring. However, considering the fact that Spring has 90% of the market, it's still of course a very strong option. Okay, so if we try to throw things on the ground, then this is what you have to do. But if you want to interact with an LM, well, then you probably have to do something slightly different. So what I'm going to do now is show you a bit of LangChain, a bit of Spring AI, that you get a feeling of how does this work. And instead, I'm going to use LangChain for J first in Spring Boot, because I assume you would most probably use it in Spring Boot. So what you need there is simply a bit of configuration, and configuration is more or less always the same. So I need an API key, pay, right? I need a model name, temperature. So temperature defines how factual the reply of an LLM has to be. So with temperature 0, I get very factual information, and 1 would be kind of very wild, creative output. That really depends on use case. However, in all cases, you can still expect hallucinations. Important to remember. Okay, so then when I have this configuration, then I get this chat model being automatically spun up for me. And then when I want to do some interaction with an LM, then this is how you do it, right? An endpoint, simple chat model, chat. Easy peasy. Let's show how this works. And in order to do that, I'm going to use Kotlin notebooks. Who of you has used Kotlin notebooks? Ooh, that's not that many yet. But it's a very, very cool and powerful tool. The way this works is I can define some code sections, as you see here, where I do some requests, create now a get method. Then I can execute a piece of code, and from there on, it's in my sheet available. Then I have also some markdown sections where I just can put some documentation. And now I'm going to use my particular method to call the endpoint we just created. Is Kotlin frequently used in Dutch financial institutions? Yes, it is. And the trend is increasing. That's definitely no hallucination. If you look closely, then you saw the reply appear all at once, right? But if you have a lengthy response, it would be nice to get the reply piece by piece. So how can you do this? Again, piece of cake. What you would do to make this possible in LangChain for J with Spring Boot is declare a so-called AI service of a streaming form, and then import that one. This would return me a flux, you know, the Spring default for reactive stream, and then I convert it to a flow as flow, and ta-da, off you go. And with that, I now should be able, when I change my endpoint to /stream, to get my response streamed, meaning that it appears. piece by piece. So far, so good. If you would like to do the same in Spring AI, then, well, it's more or less the same experience. So you have to define an API key, you have to define a model, you have to define a temperature. They're all the same, as you can see. And then this is how you would do it. You get then a chat client with Spring's common way of kind of configuring your client to get the behavior you want, and off you go. So this would be the exact same example. Sometimes you do not want to have strings as a reply. You want to communicate with an LM in a more structured way. And that's also actually quite surprisingly simple to accomplish. So what I have here is a prompt that says, select me the most wanted dishes for a certain kitchen. And then instead of returning a string, give me a certain data structure, which is here some data classes. So a dish and some ingredients. What Spring AI will do, LangChain does that, does support these features too. It will take this data class, generate the JSON schema for it, send this JSON schema to the LM, and instruct LM to reply in accordance to that schema. And apparently this works surprisingly well. Of course, also there you can get hallucinations, but generally it kind of works well. Like as you can see here. So what kind of kitchen we're interested in? Italian kitchen. And now I expect JSON as a reply. So that works pretty well. So far, so good. Okay, then what Spring AI is particularly good at, and LangChain for J does not support this feature, is when we include some media in our prompts. As you might know, for instance, OpenAI, you can just send images, voice fragments, and so on, and it'll then also take this into consideration. That, of course, really depends on your model. If you use an open source model on your machine, they're not going to support this. But the paid model, they do that. So it's very simple. I say, this is my prompt, detect all the objects in the image, and then I pass in URL or an input stream, whatever, and then let the model do its thing. That's what I do here. So I have an URL of some image. In Kotlin notebooks also can depict HTML, so I can nicely kind of show what I want you to show. Then I put this URL in my endpoint, and then, again, piece by piece, the AI will detect what's all in my image. And that looks pretty decent. Okay, I would say so far, so good. But we, of course, want to build something serious, not just interact on a request basis with an LLM. We want to build an LLM-enabled application, which apparently isn't that simple. There are quite a few failures by now. This is an interesting one for McDonald's, which had to take their voice-based ordering system completely offline because people ordered a Mac and they got 100 McFlurries, something like that. So it really went head away. What's important to mention here is that this project was started in 2019, which of course the state of AI was never as far as it's now. So let's see if we today can create something better than what McDonald's tried. And of course not for fast food, but we like to create something delicious. The AI-powered Italian restaurant, Italian Delay. And on the go, let's see if we can kind of capture all the important concepts needed to build something like that. So what does this application have to do? Well, it needs to be able to interact with the menu in a, natural way, natural human way. And of course, we need to be able to order something. Which brings us to our first problem. How do I incorporate my own data with an LLM? An LLM is kind of black box. How can I kind of give my data to it? There are two ways of accomplishing that. You could fine-tune an LLM. How does it work conceptually? Well, you would take an LLM, you would freeze certain stuff, and then take your own data and retrain it. The problem with this approach is that, first of all, it's very costly, for one, and for second, if your data changes, which in my case it does on a weekly basis, because every week I have a weekly special, I would have to retrain my whole model. So this approach is probably not our approach for our use case. This approach is often used for very specialized models, for instance, the one for code completion. What we would like to do is this particular practice, Retrieval Augmented Generation, RAG. So who of you has heard of RAG? Quite a few, cool. Who of you knows exactly what this Retrieval Augmented Generation means? Ha, That's less. Okay. So hopefully you're going to learn something today, even so you have already heard from RAG. So conceptually, it's quite simple. I get a prompt, and then I take that prompt and look up similar data to that prompt. Similar data to that prompt. Okay. And guess what? This is the retrieval step. Then I'm going to send my prompt to the LM, but I'm not only going to send my prompt, I also send the data I looked up. You can guess maybe once, this is the augmented step, right? I augment my prompt. And then what's left? Generative AI, the generation step, where the LM now generates an answer based on the prompt and additional data I've included it. That's where the word RAG is coming from. There is a more down-to-earth name, which I personally like, stuffing the prompt. If they have used that, I think the whole world would understand this concept much better. Well, this sounds kind of very straightforward, but there is definitely something interesting going on here. How can I find similar data? That's a different order of complexity than just your traditional SQL-like query, right? There's something interesting going on there. In order to understand what's going on, I think it's good to take a step back and look how we can achieve this. And for this, we need to look at NLP, Natural Language Processing. So what is NLP? Well, NLP is the field in AI that allows computers to understand and create human language. And with that, we can do something like this, similarity search. So I can take the word pasta and then get also similar words like pasta. That's what semantic search or similarity search is all about. And the cool thing is this also works for whole sentences. How does that work? Well, it's actually quite smart the way this approach is. So the way this is done is that you assign meaning to words by means of an n-dimensional vector. That's again a whole mouthful. What is an n-dimensional vector? Well, that's just simply an array of numbers. And every dimension of this vector represents a characteristic of a word. So index position 0 of this array would be orality. This would be the characteristics for index position 0. For 1, masculinity, and so on. And then every word would have the weights assigned for every dimension. And as such, we can capture meaning. Generally, we have about 300 till 2,000 dimensions. And of course, the more dimensions you have, the more accurate you can depict what the word means. And of course, also the more processing power you need to work with this data. The question, of course, is how do you get those weights assigned? You're probably not going to do this manually, right? That would be quite a tedious job. Well, for this, of course, rely on training. And the way this goes is you take a large corpus of text, a lot of text, and then, by just training the model, these weights should actually emerge automatically. Because in the text I provided, it is very likely that the word queen is strongly associated with rurality and femininity, but not with masculinity. Which is also something we need to be very aware of. It really depends on the corpus you use to train your model. If we try to create a model for programming languages and we just take some science fiction books for it, you'll probably not get out the right relationships. So that's important to realize. Once you have trained such a model, we are not really talking about the vectors anymore. We're talking about an embedding and an embedding model. Okay, under the hood, it's slightly different. I think it's good to understand that too. So let's just go one step further. We're actually not vectorizing words. We are vectorizing tokens. And I guess all of you has heard tokens, because when you interact with an LM, you pay in tokens. Because LM do this internally too, by the way. So this is actually a part of an LLM. So when you train such an embedding model, you not only get the embeddings, you also get a so-called tokenizer. That's part of the output of the training run. And this is what a tokenizer does. It takes a string, the queen rules the kingdom, and these are the tokens it will create out of it. And you see that king and dumb are actually two tokens. So why are we tokenizing stuff? Well, the reason is that you will reduce the vocabulary, and as such, you will better capture semantics, but also make the whole process, of course, more efficient. Then we assign unique ID to every token, and from there we simply can look up the corresponding vector in our embedding model. And now comes this cool thing. This also works for sentences. How could that be possible? Let's take the sentence again. The queen rules the kingdom. So what you would do is you would simply look up all the individual vectors of all the tokens and then apply some pure math. So no more training, no more deep learning, just math to aggregate those vectors into a single one. And then you see that this vector here scores about as high for masculinity as femininity, because in the whole string, masculinity, queen, and king, femininity is represented as much. And this is how you can give meaning to whole sentences. Okay, so that was maybe a lot of theory. So let's make it a bit more tangible. And for this, we're going to use the tool set of LangChain for J, the parrot here. And in LangChain for J, you just can pick an embedding model. That's the one I picked, the All-Mini LM L6 V2. You have to look up the definition, how it's trained, and so on. I can execute that. And now, for instance, can look up the embedding for the word pasta. And you see that my model now has 384 dimensions. So that's not that much, right? The rich models have about 2,000, it's 384. This is the ultimate proof there is really a vector beneath it, right? An array of numbers. That's what's beneath such a model. And when we look at how many tokens we use for that, a single token. So apparently pasta was mapped to one token. If I would say I love pasta, then guess what? You now have 3 tokens, but still one vector. Not 3 vectors, still one vector, aggregated. So why are we actually vectorizing stuff? Why are we creating arrays of numbers? Well, computers, they love numbers. They can handle those very well. And because we have numbers now, we can, for instance, compare 2 vectors and see how similar they are. And for this, we also have a variety of algorithms. There's also no deep learning, just math, pure math. And a very famous algorithm for that is the cosine similarity algorithm. And with that, I can now, for instance, see how similar 2 words are. Is seafood similar with lobster? Pretty similar. 1 would be identical, 0 would be not similar at all. And as proven, it also works for sentences. Seafood with spaghetti is very similar to lobster with pasta. Okay, so now this might look like a bit like a wonder machine, that it just really knows everything that's similar. But if I would say Kotlin similarity with programming language, which I think we all agree is something that should be scored quite high in similarity, right? But it does not. 0.15. Why is that? Well, because the corpus that was used to train this model apparently didn't contain any programming language and also words and content that is related to it. So this relationship is not represented in your embedding model. So your similarity is only as good as your embedding model. That's really important to realize. You cannot just pick any embedding model and then expect perfect similarity searches. Okay. So how can we leverage this concept for application, right? This is what we want to write. What we would like to do to leverage this is take our menu and vectorize portions of it. Portions of it. Kind of fits to a restaurant, right? What's also important to mention here is what you vectorize, that's actually kind of dark art by itself. That's an area of expertise. What you vectorize is really up to you. If you take sentences, words, paragraphs, you name it, as long as you get the right results out. And there are 100 approaches out there. We keep it simple today, right? Because we just focus on the concept. So we're probably going to take a dish name and ingredients, because I believe that the user either looks for ingredients and then wants a dish for that, or looks for the dish itself. Then we have vectors. But vectors themselves, what can I do with it? They're just a bunch of numbers. I need to store them somewhere. And this is where vector databases come in. More on that in a minute. Now I have a database that kind of can do things like similarity searches with vectors. Now on the incoming part, do the exact same thing. I take a prompt, I vectorize it, and now it's vector against vectors, and so I can perform my similarity search and say, give me the 5 most similar things back. Okay, when it comes to vector databases, the good news is that PostgreSQL, which I guess most of you have used or even on a daily basis, has a very good vector extension. So you simply install the vector extension, and then you can convert your Postgres into a vector database, at least a capability. It then has capability to work with vectors. You also can embrace a more exotic counterpart. As you can see, there are a lot of them out there, but Postgres does the job pretty well. Okay, this is what we're going to do right now. In Spring, in Kotlin notebooks, you have this very cool feature called a data frame. A data frame is a great building block to analyze all kinds of data, even in a kind of type-safe way. So here I have my menu as CSV file, and here it just shows me what's in the CSV file. And we have a dish name, a category, and then we have the ingredients. Here I'm going to define what I'm going to vectorize. And this is exactly what I already told you before. I'm going to take the dish name and the ingredients, so without the units, and this is what I think will make my job work. But that's it. That's up to you. So then I have a bunch of documents, and now I have to ingest those documents into my vector database. And for this, I can rely on the very powerful tools of LangChain for Chain. Spring AI has them too, by the way. So I would define my embedding store, which is my Postgres database. I would define so-called ingester, which is a combination of my embedding model and the store. And then I can start ingesting my documents in this database. Ingest. 157 dishes I have, quite a lot. Okay, with that, we are almost there, because now we can do similarity search. Data frames also can work with SQL databases. It's quite awesome. I just give the string, and then I can treat it as it was a CSV file. So what have we done? This is what we've done. So we've created this text and create an embedding for it, a vector. Now, I could take, as you've seen in the slide, a prompt like this one, a dish with noodles, seafood, mozzarella, and so on, vectorize it with the same model, that's very important, with the same embedding model I used to generate the vectors in the database. Otherwise, these two vectors wouldn't kind of match with each other. Crucial. And then I could do just, at least with Postgres, do almost a normal SQL query with one special operator. It's this one here. So this would be the embedding in the database. This would be what the vector I provide here. And this operator then would apply the so-called call sign similarity algorithm. And there are other ones, pure math, right? How you can compare vectors. And with that, I now can see that with a min score of 0.8, I would get those similar dishes. And I think it does it quite well. I can raise the bar, and then I get more accurate hits. Okay, so far, so good. What we need to do next, of course, is create now our chat application. And for this, we're going to use Spring AI. Before we're going to code, it's also important to be aware of how we talk to an LM, what kind of protocol is used. It's not the case that we simply send strings to it and send strings back. It's basically a very structured protocol. It works as follows. So it has these messages, and then it has these objects, and you have so-called system role. You might have heard of it. This is the system prompt, which gives guidance to the whole conversation. Then you would have the user role, which is what the user has entered, including additional context we added to it by means of rag. Then also something about tools, more on that in a minute. This will be sent to the LM, and LM will reply in the so-called assistant role. So this is the way we communicate with LLMs. It's pretty standardized nowadays. When humans communicate, you probably haven't even realized it, but we kind of keep track of what we said, right? Because otherwise, you might end up saying the same thing over and over again. LLMs are stateless machines. They're not going to keep your conversation. They just always start afresh. So how do we preserve what we said before? Well, in history. So where is the history preserved? Somewhere, but not in LM, so it's normally in the system. And to kind of make the LM aware that we have said things before, we will have to resend all the history each time again. And Anton just explained it today. When history just grows too much, you can either just skip it, you can have an LM summarizing it, whatever makes the job work. But this is the kind of sad situation. We just send everything we've had before along. So messages will keep on growing. So the last one is the one the LM will pick up, and the rest it will know is only context to support the latest message. In Spring Boot, to make use of vectorization, is, again, surprisingly simple. So our basic chat would look as follows. With a bit of configuration, I would get a vector store bean. Right? The only configuration I need for that is what you see here. It's just a normal database configuration. And then you tell which kind of algorithm you want to use to do similarity search with the vectors. That's more or less it. And also something about indexing, but we don't have time for that to explain that. And then I simply can take my chat input, which is a string, and say similarity search. And it will retrieve me the documents that are similar to the input I've provided. I will also add a system prompt. As said, it will give guidance to the conversation. So here it's someone that needs to help a customer ordering a dish. It needs to address the customer with welcome to Italian delay, something I explicitly mentioned. And I also instructed that there is some context in the prompt you can use to do your thing. So here below would be my augmented prompt. Remember, augmented. The user query, the user enters, and then the dish context I looked up. So where is the history coming in? Well, that's a bit of a weird thing in Spring AI. You have so-called advisors. And here we say chat memory conversation ID. Then I have to provide my own sort of session ID, and then Spring AI will look the previous history up and will send this along up to how many? 50 entries. Okay. Let's see if this works. For this, I've coded. It was my first vibe coding experience with Junie, which did a decent job. About 80% it could do. The rest I had to do myself. Also had to kind of instruct the refactor stuff because it was quite crappy in the beginning. But in the end, it's kind of decent. I created my first chatbot, which could, because it's KMP, also work on your mobile device, on, well, everything out there. And let's see how it behaves. So now it should reply with the greeting I instructed it to do. Welcome to Italian delay. That's pretty good. I just enter some ingredients, and now I want to have matching dishes. And this is what I get. Quite decent, right? Something is pasta, seafood, and tomato sauce, and I get spaghetti with seafood, with lobster, and so on. I would say pretty good. If I tried this 5 more times, maybe 10 more times, 1 in 10, we get very weird results. All of a sudden, it started talking in Italian, things like that. And then it instructed, yeah, but you have to only do it in English. So the system prompt in the beginnings was considerably smaller, but it keeps on growing because you try to capture this case, that case, and that's the way prompt engineering goes, right? It's trial and error engineering. Very advanced. Okay. So far, so good. So I can now have my own data included in a LAM. I can kind of find similar thing. That's quite advanced. But what I cannot do yet is the most important thing, order my dish. So how can I make an LLM call my order API? Right? How are we going to make this happen? And this is also surprisingly simple. So I have my prompt here, and alongside the prompt, I do not only send, for instance, context from rack, but also send a list of tools. So what is a tool? That's what it says. It's a tool. It's just anything you can execute on a computer. An API, web search, DB, all of it. And alongside every tool, I also send a description saying, hey, this is the tool for that. So tool number 1 is for ordering dishes. And when then the LM gets a prompt that says, I want to order lasagna, then it reasons, oh yeah, I have this tool for it. I think now it's time to call tool number 1. And in its reply, it will instruct me, the application, to execute this particular tool. So I will intercept that response, I will execute it, and the reply from this execution I will again send back to LM because there might also be some valid information in my reply which LM can use to do its further reasoning and also further creation of the answer. So this is conceptually how it is working. And that's why I have these frameworks, right? You could write this yourself, but this interception step, well, there's a lot of corner case and so on. And this is what these Spring AI's LangChainFetch actually do for you. Make it very simple to do that. And you will see it's surprisingly simple. The only thing I have to define Spring AI is this here. It's a function, literally a function. That's what I define. It has an input, again, some data class. That's what you see here. It has some output. And I have to register it as a bean. Then when Spring AI sends this tool to the LM, it will also instruct that if you call this tool, then this is your JSON schema. and as such, we get this interaction. So the only thing we have to do now is adding this thing to the tools section. And with that, the LM knows, oh yeah, I have this tool web, it has this description, so let's see how it performs when I then want to do my ordering. So here's my tools. Then I say, I would like to order option number 2. Then ideally, it has ordered spaghetti with lobster, which really is option number 2. And if you look closely, then we have our print line in our log, and it said something about 20 minutes. It will be delivered in 20 minutes. So if in 20 minutes someone is at the door, sorry for that. It's part of the demo. Where are these 20 minutes come from? For this, it's kind of helpful to look at the interaction we had with the LM. This is actually the response, nicely logged. And you see here that it instructs Spring AI now to execute this order with this payload. So it nicely created also the input. Then we had our logging. What you saw just here is the history we sent along. And then the reply of my function was delivered in 20 minutes, which is sent to the LM, and LM will use that to produce its final answer. They've really improved LMs. I had this example about half a year ago, tried something similar I tried, and then when I said option number 2, then it really didn't know what to do. But nowadays, it's pretty accurate. Okay. So far, so good. What is created so far is actually more or less a closed system that has some manual instruction, and it can do more or less what we define our system prompt, right? That's what we created. But wouldn't it be nice if we could kind of expose the key components of our system, like similarity search, like the ordering, and so on, in a modular way so that other UIs, like for instance this one, Claude UI, could make use of our functionality too, right? That would be awesome. So in other words, if we, as said, could modularize our application further and then basically tools, and then expose them as a server, then we only would have to use a client as a protocol to enable other UIs that talk with another LM, right? It's not the same LM, to use the same functionality too, as long as they talk the same protocol. And this is where MCP comes in, Model Context Protocol. So if you have heard of MCP, quite a few, nice, cool, not everyone. So the server then would become the MCP server. And now server might imply that this is a kind of, a server, something in a rack in a data center. That's not the case what an MCP server is. MCP server is a very, very thin wrapper that most of the time runs on your local machine. That's an MCP server. So not the server you had in mind, what we're creating microservices or something like. It's a very thin piece of functionality that can do actually two things. So it can call remote stuff, like the ones you see here, APIs, web search, and so on. But when it runs locally, it can also access, for instance, your file system. It can execute operating system commands. So it could delete your whole hard drive. That's possible, right? Well, when you have a server, you also probably need a client. And this client then is running on a so-called MCP host. And the protocol they use to interact between each other is the MCP protocol based on JSON RPC. So MCP was actually launched by Anthropic, the company behind Claude, and it has become quite a bit of a standard. So even OpenAI plans to deliver it in its latest edition of one of the future editions of the ChatGPT client. So it's becoming a standard. That's the way it goes, right? If someone creates an implementation that is good enough, others will follow. The nice thing is I can, of course, also have a variety of MCP servers. Now, as such, get quite a few functionalities into my chat application without the need for me to create my own. Okay, so let's first take a look at MCP server. What can it do? It actually can do three things. It can deliver prompts, kind of predefined prompts, or in prompt templates you could specify them further. It can deliver resources, that's really just data. And last but not least, tools. That's really the same thing what you've just seen before. tools that execute stuff. These are the three capabilities of an MCP server. MCP client would then first discover those capabilities, because a server doesn't have to expose them all, at least one. That's handy, right? One. It can retrieve data when you have resources, and of course, it will also handle the tool execution. The MCP server often is a given, right? That's not something you're going to write. You just take one off the shelf. There is a nice one in Kotlin. There is a good one in Java. Pick your battles. So what you will write are MCP servers. That's what you're going to write. That's why I also need to talk about the protocol, which is a bit odd. At least I found it a bit odd. But it's probably kind of nicely aligned with the presentation we had before. The transfer protocol between MCP client and MCP server is standard I/O. Right? Pipes, basically. That's really, it's a command line tool you spin off. That's one format. The second is, when you want to have remote, HTTP with server-sent events. So you have an HTTP connection, and then from there it keeps on pushing you information. In between, it talks JSON RPC. So who of you has heard of JSON RPC? That's not many. And I was one of them too. I didn't hear. I mean, I probably heard of it, but I didn't kind of recognize it. The good news is I can explain in about 2 to 3 sentences. It's really simple. So JSON RPC is a transport agnostic protocol. So it's not bound to a transport like HTTP. You can send it over every transport. And this would be the payload to discover the capabilities of an MCP server. Because JSON RPC is transport agnostic, it needs a way to tell the receiving side what to do. And this is why we have this method attribute. The method attribute instructs the MCP server to initialize. That's one concept. The second concept, it's a bit weird, but that's what it is. When I send an ID, then I expect in my reply the same ID back. That's what ID is for. If I don't send the ID, then it's fire and forget. This was JSON RPC in a nutshell. And I think there's really not more to that protocol. That's what it is. So the server then would reply, indeed, mirrored ID, 1, 2, 3, and then just give whatever payload it wants. And apparently the server supports all 3 capabilities. Okay, so let's create an MCP server to modularize our existing application. And while doing that, I also would like to make an improvement. Because if you look closely to this piece of code, I don't know if you had some question marks. You thought, is this always going to work very well? Can you see it or not? Well, the point is, I'm going to look up similar dishes for every prompt that I receive. But prompts are not always about dishes, right? So my first one was hi. My last one was I want to order. But it always tries to look up similar data. That's not very advanced, which might even confuse the conversation. And I had this, right? Then it finds a dish on the word hi, because apparently there's some vector match. And then I'm thinking, okay, I think it wants to order something. Ooh, totally weird. So how could we improve that? Let's see. So before we write MCP server, we first, as said, going to modularize applications. We're going to expose our key functionalities, which an MCP server can call. That's the way I approach this problem now. And this means that I just expose some normal API, so this is nothing special, just an API. What I'm definitely going to expose is the order service, right? We need to order. That's kind of a given. To solve the problem we just seen here, I introduce an intermediate step, which is called a prompt classifier. So what this does is create or sending a prompt to an LM with a prompt to instruct LM to figure out whether the prompt it has received is about food or something else. And if it's about food, then also retrieve the food elements. So I want the LM to reply in this format, say whether the prompt I've given you is about food or something else, and if it is food, then retrieve the elements. And with that, I can make, of course, a much more accurate similarity search than with just putting in a prompt. So this is kind of a trick. And of course, the trade-off is that I have an other interaction with LM. That's the price for it I pay. Then with basically the list of items, I can also expose my vector search. And instead of just having a prompt, I now have an element of food items. Okay. These components and I want to expose or access with an MCP server. How do you write an MCP server? There's a cool Kotlin SDK, MCP SDK, which is straightforward. So I have here a server. Here I define the capabilities I want to offer. So when the client does its initialization, then it will see, oh yeah, this server has these capabilities. And of course, we want to define a server with all capabilities. So let's start first with a resource. What would be a good resource for our server? What we haven't done yet is exposing the whole menu, right? But maybe someone just wants to kind of scroll the menu and see what's on the menu. And that's an ideal case for a resource. The way this works, I say server add resource, I give it a name, a description, and this is basically the resource in MD format I will return. Okay? Then the next step would be to create an executable jar of this application, an executable jar, because it runs as said as a command line tool, executable jar. So once we have this, I have to configure this particular command line tool in Cloud. You have here develop section, it's all pretty new. You say edit configuration, and this is more or less how the configuration looks like. This is it, this is basically it. So it says execute Java main jar your application. So it just starts out this application. It uses standard I/O to communicate with it. So literally, it talks to command line tool. That's what it does. And with that, I should be capable of navigating the menu. When I want to use a resource, I have to select it explicitly. You see now it's appearing here in Claude. And that's what it just done in the background, right? The MCP client said, hey, give me this particular resource. And from now on, my conversation will consider the resource I just provided. So give me the main courses of Italian delay, and it should take those from a menu. And that's what it does. It didn't invent stuff here. It's really from Italian delay. Okay. What's left is probably the most important part, which are prompts and tools. Let's first look at the tools. The tools are basically just the wrappers for the modules which we have exposed in our original application. So there we go. It's a lot of code, but the gist is simple, right? I say server, add tool, name description. And what's really annoying, and I think the SDK could improve that, for instance, here I have to provide a schema myself. That's very tedious to produce. They could have give you better tools to solve that. Yeah. Feel free to open the pull request for that. So here I have my classify prompt if food or other, right? That's the one we want to expose. And then we have basically the find dish service. Also here I have to provide a JSON schema. And the last one is the order dish service, again with a JSON schema. And now my tools, so my actually executable parts of my application, have been exposed with an MCP server. The last thing that remains is, of course, a prompt. So what would be a good prompt to expose? Well, it's probably similar to the system prompt we had before, right? Give guidance to the whole ordering process of my restaurant. So that's true. It's very similar to that, except that it focuses more on the tools available. So here I just explicitly list the tools it can use to do the different steps. And this helps in the whole conversation. It's not strictly necessary, but it definitely helps to create clarity for the LLM. And with that, I'm now very confident, because I recorded it before, that it's going to work. So also a prompt you have to select yourself. That's something which is magically done. You have to select, and this prompt will now guide my whole conversation. Then I say what kind of ingredients, the dish, at least the dish I want with the ingredients I had in mind. And now it also prompts me if it executes something like classify now my food. So there's security built in, which ensures that you will give consent to do it. And you see this classification worked quite well. So now it extracted the food elements out of my prompt. It also called this find dish service with the extracted elements. And now I get a pretty accurate hit. That's pretty okay. It's more or less what you had before, but the order is slightly different. For ordering, really the same thing happens, right? The order service is now called. It realizes, oh yeah, now it's time to order. I need to have consent. And then last but not least, it says that, again, in 20 minutes, I get another dish. So, and in the background, you just saw the JSON RPC communication going back and forth. Okay. Well, what are we still missing? I think we're still missing a bit of a dessert, right? Something like the next level interaction between humans and machine that only big tech can realize, but we as normal developers. Something that allows us to talk to a machine and let the machine talk back. How hard can this be? Surprisingly simple. For this, I'm going to use Spring AI because LangChain Chain doesn't support that feature, which is basically transcription of audio to text and converting text to speech. That's all it takes for that. So let's see how we can accomplish that. Oh, that's the simple one. It's not the one we want. So what I've introduced now actually two new steps. This is the chat method we had before, you know, the bit inferior one that always looks up dishes. For now, that's good enough. Just to show that we're not going to change the core logic. We're just going to change the input and the output. That's basically what we do. And for this, we're going to use this OpenAI audio transcription model that converts an audio stream I get here into text. The text will be fed to my chat. The reply of the chat will again fed to an OpenAI audio speech model, which then returns it back to an audio stream. And then the only thing we need is an application that does that. So this is what I have here. Do you have tiramisu? It's not very hard, but it said, do you have tiramisu? It has to think a bit.
We have both the classic tiramisu and eggless tiramisu available. Which one would you like to order?
I go for the classic. Nothing fancy.
Thank you for your order. You've chosen the classic tiramisu. It will be delivered in approximately 20 minutes. Enjoy your dessert.
20 minutes, you got dessert and outside. And you see, it's a few lines of code for a delicious dessert. Okay, and well, with that, I hope that we all can embrace a future with AI with confidence while enjoying all the delicious treats from our newly created shop, Italian Delay. And ideally, all leave this room as, hey, I rose. Thank you. Maybe some moments for questions. Yes.
Hi, Urs. I had a question about the part before the MVC where you introduced the RAG. And you also explained how basically tools could be used for anything. So I imagine you can also use a tool to do the database querying instead of stuffing the prompt with it. So what is really the advantage of stuffing the prompt with it instead of using a tool?
Yeah, so that's a very good question. You also see actually different strategies. For instance, LangChain Chain has this kind of RAG routing, so that you get a request and then it tries to decide, maybe even with a local LM, that they don't have so much round trips, to decide which source to have to kind of ask. Now it was a simple menu, but in a real enterprise, you maybe have a lot of different kind of data sources which you need to discover. So if you do it with routing right away, it's probably faster. If you do it with a tool, it's probably more accurate, but it takes longer, right? Because when you do a tool, then you can also maybe say to LM, hey, extract the crucial parts for then calling my vector search with a tool, but you have way more interactions going on. And this is something in system design that probably you've seen it. It takes a long time. Right? This was a good internet connection. So when you design your systems, I think often it's a trade-off between accuracy and speed.
That's clear. Thank you.
Hi, thank you for the presentation. It's really nice. And my question about the prompt classifier. why we can't use the system messages to guard the LLM to classify our prompts instead of doing prompt classifying in the middle.
Yeah, the problem is that you could do that, but in the end, I want to have the classified message to do something with it. Otherwise, LM would classify it, and then I get a classification back, but then I don't have anything else yet.
I was thinking about like guarding it. If it's not having food, don't process it as against my my augmented data, something like.
Yeah, that's indeed also an approach you could indeed do, and that's indeed something also I did in the beginnings. The drawback is then your system prompt getting very, very large, and the larger it gets, the more unreliable the LM will be. So it's a very precarious kind of balance to figure out the right approach in also amount of context to give it and instructions to get the desired result. And this is something what I'm also really surprised with this kind of application. It is really kind of trial and error of the first order. Yeah, cool.
Thank you.
Hello, thank you
Hello.
so much for the presentation. I do have two questions actually. First question is that I thought that you have uploaded your executable jar into the cloud. So my question is that regarding the product perspective, let's say that we want to deliver it to a customer, how we should provide this jar file to the customer? How does it work in the real world for the end user?
Yeah.
And the second question is that how do you handle the security when you are using the MCP server?
Yeah.
Thank you.
So that's indeed a very, very good question. You see that often with these kind of developments, security is, well, not probably the primary thing they do. In cloud design, they did this because it was so crucial. Otherwise, nobody would put computation power on the cloud. So they're really kind of put security as a primary citizens. Here you see that they thought to a certain degree about it. So what you said first is whether I uploaded my tool to the cloud. That's actually not what I did. So the example I showed you is that it reruns on my local machine. Because it runs on my local machine, I need to download it somewhere. So you often see JavaScript clients where you have to some command that it downloads really a package, which of course is also from a security point of view a nightmare, right? If this is kind of some malicious code, then it will do very, very evil stuff on your machine. So that's precarious. The reason why I had to do this is because Claude for now only supports the standard I/O interaction. So not yet the HTTP server-sent event interaction. When you want to host an MCP server in the cloud, then you would have to use such an HTTP variant. And the way you authorize it is then something, now the way it works, you've seen it, you're prompted whether it's okay to call that tool. That's the only security you have. And otherwise you have to create your own client using an MCP client SDK, and then use just normal tokens to call then actually your MCP server.
I had another question. First of all, thanks, Urs, for the talk. And secondly, I was wondering what UI framework did you use for the chat interaction, the chat and voice interaction? It didn't look like a website.
I said I used an KMP application, Kotlin multi-platform application, which I should also be able to compile to a browser, which I haven't done yet. And the only kind of operating system part that's probably not very portable is that I create MP3s. And for this, I need a special encoder, which runs on my machine. But that's actually what I used. And then you just create, basically, from an audio stream an MP3. You send MP3 to the server, it sends it to the LM, and so on. And then it plays it with my audio system. Yeah.
Thanks, of course. It's full stack Kotlin. I could have expected that.
Exactly. One more.
Thank you for the presentation. You mentioned at the start there's mostly two frameworks to use, LangChain and Spring AI. Recently, we've also seen JetBrains release Koog, or how you want to call it, pronounce it, and also Mbabel. And I was wondering if you're familiar with those and if there's any opinion about it.
Of course, I'm familiar with that. But unfortunately, I didn't have time to even extend this presentation with it. What you see is actually now kind of agentic frameworks occurring. So agentic frameworks are very similar to tools, but they often work by means of a graph. And this means actually that you have an agent, like coding agents, which basically is a program by itself, with also kind of system prompt. That's the way you can look at it. It's a program with a sort of system prompt and tools it can execute, but as a module. And then the graph comes in when you say, okay, I have now one agent with system prompt and tools that can talk maybe to another agent doing stuff. For instance, if I want to book a journey, I have an agent for my flight, I have an agent for my hotel, an agent for my car rental, and then probably have a booking agent that again talks to D3. But then when it goes really specific to ordering or booking a flight, then I would be at the flight agent. So by doing so, you can kind of decompose a large set of functionality into separate, isolated pieces that are still connected in a functional way. And Cork, for instance, offers you this agentic approach, and they also actually plan to kind of integrate this in Spring AI, because they now also reinvent a lot of stuff themselves, like calling tools and so on. So I'm also curious what Spring AI and LangChain are going to do. They don't have this yet. LangChain has LangGraph, but not for Java. So it's a field that is extremely in motion. But I think this graph aspect we will definitely see occurring in the coming months. Yeah. Cool. Yeah. One more. Then the tiramisu is delivered. So.
This rack architecture seems to be pretty secure, because what you do, you just compare those vectors, right? And the user input is not, it's really discarded, right? It doesn't go back. But I noticed with those tools, it's not like that. And basically, I could imagine a vector of an attack when I send something that it would perform malicious thing on your computer. Like probably you could even create some, do service discovery of those services, and I could get it as a user, right? Is it possible?
Yeah, that's called prompt injection. That's a new kind of threat we have, that people will, when they know, for instance, when they send email to some endpoint, some information from a company, and they know it's treated by an AI, they're going to instruct in their email the AI to do stuff for them and send them information and so on. So this is a whole new kind of security loophole. Mm-hmm. We are just actually beginning to realize what kind of danger we created with these AI systems.
I ask about, because this rack seems to be really safe, but as soon as you added those tools, I noticed that it really gets vulnerabilities quickly if you don't know what you're doing. So,
and there are different reports that stating that it might be turned into a nightmare. That's especially when agentic really lifts off and every company automates work with agents. Then, because also now, also probably ING has experienced that. That's what I know, because there's a project going on within ING to kind of also make a chatbot do what it wants. Guardrailing things, that's really a babysitting task you will get as a developer. That's a new kind of job you will get, babysitting applications, because every day they can do something crazy and then you have to bring it up and no, this is not what you can do. And then you have to kind of adjust guardrails and increase them, even sometimes manually check things. So we get a totally different kind of life cycle in terms of software development if these systems really hit production.
Okay, thanks.
Cool. Yeah. Okay, cool. Thanks a lot. Enjoy the coffee break.